my name is Cam, and this is my Physics 2211 Lab 2 report. Introduction. This lab's purpose was to compare the projectile's motion that is affected by gravity and drag force. The first computational model doesn't consider drag force, while the second one does. We will compare these two models, the observed one we will have in Tracker. The computational model with drag should ideally be closer to the observed model than the one without drag. Here are the fundamental principles and equations we use: force of gravity, drag force, position update, velocity update, and Newton's second law. Lab 2's procedures were to film a video that captures a wadded up paper ball being thrown within a still frame, to send that same video to the Tracker and start frame by frame tracking the movement and position of the ball, then put that to GlowScript to create a computational model of the ball in the air and find the proportional constant drag force to create an output for the code. Then we want to plot the data gathered from the experiment and the code to compare the outcomes of drag, no drag, and observation. Some initial parameters of the experiment were system, being the paper ball, surroundings, the gravity and air resistance / drag force, the initial position from when the ball was thrown, the initial velocity for which the force applied to the ball when it was thrown, mass of the object, and the time it took for the ball to reach the ground. This is some of the data we had in GlowScript. You can see our equations that were used and plugged in here to get our data, with the constant drag force that we used as well to get as close to the data gained in Tracker. This is showing the graphs of the trajectory without any drag force, so when b was equal to 0. And this is after we applied it with the coefficient, which was 0.00189. For the comparisons of all of the data we have gathered throughout the lab, you can notice that the distance of the no drag slopes from the observed and with drag slopes are vastly different. Green and yellow are considerably more off from the other slopes when compared to their starting points, in other words. Using that same graph, we can conclude that the computational model with drag force made in GlowScript is far more similar to the observed model made in Tracker than the computational model made without drag force. Drag/air force made an insignificant difference due to the short amount of time the object was in the air and its overall weight. Possible sources for error include human-made ones when using Tracker or calculating the initial velocity and potentially applying a non-constant force to the ball when it was thrown. Some observations where the terminal velocity occurs when the drag force going up equals out the the force of gravity, and creates a net force of 0. This makes the net force on the object predictable, of course, because we know what it equals. The model closest to reaching ideal terminal velocity was the computational model with air resistance, if you go back to the graph. And the observed object, however, did not reach terminal velocity with the data gathered when we put it through Tracker. Some what ifs. If the object was thrown straight up in the air with the same initial speed, the object would take longer to reach the floor if it was thrown straight up instead of in an arc, as gravity would have to decelerate the object as it reaches its max height before starting to descend. However, this will not create a difference on if it reaches terminal velocity or not, as that is not affected by how much initial velocity was applied to the y component. Thank you for watching.